This presentation on risk and return is for undergraduate finance students. I'm Pat Obi, Professor of Finance, Purdue University, Calumet. I've summarized the presentation outline here, but these will be given in bits. To start out, we identify the investment objective function, which you learned in an investments class, and that is to maximize your expected return for a given level of risk. So that, for example, if presented with two options here to invest in stock A or stock B, and given, as you see here, that these two stocks have the same level of risk, measured perhaps using standard deviation of their returns, as I'm going to demonstrate shortly, you want to choose stock B because stock B promises to earn a return that's higher than that of A, twice as much actually. Alternatively, the objective function can also be expressed as minimizing your investment risk for a given level of return. So that in this example, given that stocks X and Y have the same expected return of 10%, you do want to choose stock X because it promises to expose you to a lower level of risk. Here, as you can see, it's only 15% compared to stock Y's of 30%. So with that objective function in place, we make the assumption that investors are risk averse, and we also make the assumption that investment returns follow a normal distribution. Now, the power of this assumption right here is in the sense that if investment returns are normal, as I show here in this frequency histogram, then we only need the mean of the distribution and the variance of the distribution to fully characterize your investment performance. We're going to use the mean to measure how much you can expect to earn, your rate of return. And we're going to use the variance or standard deviation to measure your risk exposure, so that the greater the standard deviation of the returns distribution, the more risky the investment. And that makes sense because if this distribution is more dispersed, then it means that you're less likely to earn the central distribution. Remember, when a distribution is normal, the mean, which is the average of the numbers, is going to be at the center of the distribution, which is also the median. But observe that the center of the distribution is also where you have the mode, which is the observation occurring most frequently. So with those two assumptions, and without further ado, I'm going to show you how to calculate your investment beginning with a single investment. For a single investment, we can use either historical data or we can use probability data. Now, for historical data, for example, say over the past 4 periods, we obtained sample data of how much a certain investment earned. Like a year ago, it made 5%, 2 years ago, it made only 4%, and 3 years back, it lost actually 7%, and 4 years back, it earned 9%. So to calculate the return, all we got to do is to simply calculate the arithmetic average that we learned in grammar school. Simply take the average of all the numbers, and here our result is 2.75%. So if you believe that history will repeat itself going forward, then you are saying that if you were to make this investment, you can expect to earn about 2.75%. How about risk? Well, we can use the variance of the distribution, as I explained earlier on, to measure how much risk you're exposed to. The definition of variance here means that we're going to have to subtract the mean from each of the possible returns, as I show here. So the mean is 2.75%, subtracting it from 0.05 in the first instance, 0.04 in the second instance, etc. And then dividing by n-1 degrees of freedom. You always have to do n-1 degrees of freedom, which is a sample size -1 whenever you use sample data. The logic of that you learned in statistics. So in this example, I go back, since we have only 4 observations, which is a sample size of 4, then degrees of freedom would be 3, and that's what you see right here, 4 minus 1. So final answer, 0.0047. And this is our measure of the absolute risk of this investment. Meaning what? Well, if this were 0, then we're saying that we have absolutely no risk in this investment. Variance cannot be negative because variance is a squared variable. So this tells us that the larger this number is, the greater the overall risk exposure. So you can compare the variances of 2 or more investments. The one with the most variance has the largest risk. But looking at the variance of a single security in and of itself, you really cannot say, well, if its risk is too high or too low. Obviously, the more it tends towards 0, the lower the risk. Now, a couple of things. One is, because variance is a squared variable, you want to leave your answer as is. You don't want to say that this is equivalent to 0.47%, trying to correct the decimals and stuff like that. Typically in statistics, you do not apply a unit of measure to variance, in spite of what you may see in some finance textbooks. So variance is just a number as is. The larger it is, the greater is your risk exposure, as I said before. The second is, if you want to impose a unit of measure, then calculate the sample standard deviation. Standard deviation is the square root of the variance, and as you know, this radical sign here is the power of 1/2, which knocks out this 2. So by taking the square root of the variance, you calculate the standard deviation and therefore are able to impose a unit of measure. So our final answer here is 0.0685 or 6.85%. And typically, most investment analysts would use standard deviation as their final and more succinct measure of the risk of an investment. Finally, you can also calculate the risk of an investment by calculating the coefficient of variation, which is simply the standard deviation divided by the mean. Here, it comes out to be 2.5. So by looking at standard deviation with respect to the mean, you simply are trying to calculate how much risk you face per unit of return. And in this example, you are facing 2.5 units of risk for each unit of return. The larger this number is, the greater is your risk exposure for every unit of return that you're expecting to enjoy. Now, what I've shown you so far is the hand calculation method that we learned back then, but we can also put this on spreadsheet and use the appropriate functions. For example, this is our data set. For the mean, you can simply use the average function. You can type in uppercase or lowercase and then open parenthesis and highlight these for numbers, close, and then enter. And that's your mean. For sample variance, you can use the VAR function. That's going to give you sample variance. You can also put VARS, all right, open parenthesis and highlight these numbers, close parenthesis, and that is your variance. For sample standard deviation, you have two choices. One is you can use the square root of the variance, SQRT, open parenthesis, click on the variance, close, and enter. Or deleting that, you can use stdev. If you use the stdev function, open parenthesis, and then go back to the original data and highlight. There you go, close, and that's it. And finally, coefficient of variations doesn't have a function. Simply hit equal, click on the standard deviation, and hit the / key, which would divide it by the mean right there, and then hit enter. And that's your coefficient of variation. So going back to the presentation, that is actually the ways that you calculate the measures of risk and return using historical data. But what if you don't believe that history will repeat itself? Then in which case you're going to have to use probability data, which means, for example, that you're going to have to consider the possible states of the economy, for example, that may occur going forward, and then make a judgment as to the likelihood of the occurrence of each of these economic states. In this example, we think there's a 20% chance that the economy will falter, a 50% chance that we're going to have a moderate growth, and a 30% chance that the economy will have a strong growth. remember, the sum of your probability values has to be equal to 1. So based on this, and given some other analysis that we may have done alongside with our colleagues in the investment services industry, so to speak, we are projecting that if the economy falters, we could lose as much as 8% on a certain investment. If we have a moderate growth economy, we can expect to earn 10%. If the economy will really boom, then we can expect to earn as much as 20%. So with this in view, we can calculate our measures of return as well as risk. For return, we use the mean of the probability distribution, which is so defined, meaning that for each possible return, we multiply it by the corresponding mean. That's what I've done right here for each of the possible returns. So for each of these returns, multiplied by the corresponding probability, and when you do so, your final answer is 9.4%. So you're saying that all things considered, you expect to earn about 9.4% on this investment. For risk, variance. This is the variance of a probability distribution. Here, with probability distribution, remember, you do not divide by n minus 1. Rather, for each of the squared outcomes that you have here, you'd multiply it by the corresponding probability. So for each of the squared deviations, subtracting the mean from each possible return, squaring it, you'd have to multiply it by the corresponding probability, and that's what I've done here. So this is the mean subtracted from the first return of negative 0.8, square that, and then multiply it by 0.2, which is the corresponding probability. That's what you see going back right here. So subtracting the mean from this negative 0.08 and multiplying by 0.2, right? And that's how you have the results that you're going to have here. And you want to, using your calculator, make sure you store it. Hit store 1 on your BA 2 plus if that's what you're using to do this, which is what I recommend all the time. So anyhow, you do it for all of them, and that's your final answer. And again, leave your variance as is. Do not try to impose a unit of measure. This is not going to be any, this is not the same as 0.94%. No, leave it as is. If you want to impose a unit of measure again, take the standard, calculate the standard deviation by taking the square root of the variance. And your final answer here is 9.72%. And as well, you can calculate the coefficient of variation, which is going to be the standard deviation divided by the expected return, which is the mean of the distribution. And in this example, we have it showing to be 1.03, which tells you that each unit of return goes with a little over 1 unit of risk. Incidentally, when we have probability distribution, as we have in this example going back, there is no spreadsheet function to perform the calculation. If you want to use spreadsheet, then you want to put all these numbers on your spreadsheet and physically calculate them out. And that should also be quite simple and quick. But this concludes this first part, introductory part of the presentation on risk and return.